Last time we introduced optics, and at the time we said light was made up of 6 different colors: red, orange, yellow, green, blue, violet. Today we're going to talk about colors, theories of light, and unfortunately there's more than one. And what that means is when we perceive color, when we look at something and we say, hey, that thing is blue or that thing is green, what does that mean? And then how do we not only perceive color, but when I start mixing colors to get different colors, how does that happen? So there's going to be 2 different color theories to handle that. So here they are. One is called the additive color theory. And the most important thing to understand right now about additive color theory is that means I'm going to take a light of one color, maybe red, and I'm going to take a light of a different color, maybe blue, and I'm going to shine that together. I'm going to shine them together and see what color I get when they combine. Or maybe I'll take a third color and mix them in together, but I'm going to be taking light sources and putting them together. The other color theory, or the other mixing that we can do, is when we use what's called the subtractive color theory. And what happens in that is we're mixing, and this is where we're mixing paint or pigments, or we're looking at a yellow object and I'm shining white light or some colored light on that yellow object, and what reflects back to me, what color do I perceive? So it's a little bit different, and I can start to get these things confused. So we're going to go through this and get the basics of it, and then at another point we'll go through some details of the different kinds of questions that I might ask and the different ways or how to approach each one of those, and there shouldn't be different ways of approaching those. But looking at those 2 examples of what kind of question might you see and what kind of clues will you find in the question to tell you whether you're using additive color or subtractive color, because it is a common question to say, well, do I add them or subtract them? So we're going to try and straighten that out as we go through. Okay. Pictorially, additive color theory is taking flashlights of different colors and adding them together. And I want to point out a couple of things here. Number one is I've got these different colors that I'm mixing, and when they mix in pairs, I get different colors. So there's primary colors and there's secondary colors of light. And then under the subtractive color theory, there's also primary and secondary colors when we're talking about pigments. And you're going to find that that gets a bit confusing, but we'll try and sort it out as we go through. Maybe not all the way today, but eventually, yes. Okay, where do we start if we want to talk about the additive color theory? We're going to start with the primary colors. Now, I need to warn you, the primary colors are red, green, and blue. And I know some of you thought you had this sorted out, and then I just ruined it for you. The thing is, if you were in art class and you learned about primary colors, you weren't talking about mixing light, you were talking about mixing paint. Plus, what you thought was red really isn't properly red, or when you used red, it gets weird, and we'll try and sort it out. But the primary colors of light, shining light of different colors, are red, green, blue. And when you mix all 3 of those, you get white light. And again, you might be thinking, we're talking light instead of pigments. And that's important. Okay, so this, if I had a red flashlight, a green flashlight, and a blue flashlight, and I mixed them all together, I would get white. And I can try and show you this at some point. The problem is it isn't as perfect as what it looks like here. So real life and what looks here. So I'm going to stick with here because it's not exactly, it doesn't always work exactly the way we want it to. Okay, but let's look at the mixing in pairs, because that's also important. I've got my 3 primary colors, but when I start mixing primary colors, I get my secondary colors. So yellow is a secondary color. And when I mix red and blue together, I get magenta. So if you're thinking, well, that was kind of a purpley thing, it's actually magenta. And when I mix green and blue, I get cyan. So if you're thinking that the primary colors, if you were kind of mixed up with that, and now you're looking at those secondary colors thinking there's some problems there, try and keep it straight. You're going to have to keep it straight. Primary colors of light are red, green, blue. And when you mix them, you get secondary colors of yellow, magenta, and cyan. And you do need to know how those pairs go together. So how do I make yellow? How do I make magenta? How do I make cyan? Now, if you mix all three, as I said before, you're going to get white. If you look at televisions, either older ones or more modern ones, they will actually be able to produce red, green, and blue light, and they will mix them together in various proportions to get all the various different colors that we have. So for television manufacturers, black is actually one of the harder things to get, because how do you get a true black? Because just turn the lights off? It's got to be better than that. So they struggle with that. But those are the three colors in your television that make the television look like TV. Okay, subtractive color in my mind is a little bit trickier because there's more things going on. Plus, we run into the primary and secondary colors challenge again. So we're going to start with understanding how we understand light, or how we record light, or receive light, I guess, or colors. And we see something when light gets reflected off of it. Well, if somebody's shining a flashlight right in your eye, okay, that's just direct light. But most things that we see that are not themselves light, we see by light reflecting off of that thing and going into our eyes. So a green object looks green because green light reflects off. All the other colors get absorbed. So if a yellow object appears yellow to us, well, how do I get yellow light? I get yellow light by red and green. So a yellow object appears yellow because red and green reflect off of it, and red and green combine to make yellow. See, there's nothing to it. This is easy stuff. Well, the yellow object also absorbs blue, because if it reflected red, green, and blue, it would appear white. So can only reflect the colors that we would perceive as yellow, which are red and green. Too easy. Got it. No problem. So if I start shining white light, which I can get white light by using red, green, and blue, if I start shining white light on different colored things, then different colors are going to reflect from that. Now obviously, maybe not obviously, but a thing that's red, but maybe not all the way red, but maybe orangish red, it's going to start reflecting slightly different things, and we're not going to get too nutty on this. But a red object reflects red, a blue object reflects blue, a white object reflects all three, and a black object absorbs all three. It doesn't reflect any light at all. Now we know that black objects can appear kind of shiny, so they must be reflecting something, but we're going to ignore that and keep life simple. Now, I can actually get a little bit more detailed on that, and we will eventually, but right now let's talk about the primary colors of pigments, primary colors when we're talking about subtractive color theory, because that's going to blow your mind. The primary colors are magenta, yellow, and cyan, because of course they are. Why would they be different? So here's the short version. The secondary colors in additive theory are the primary colors in subtractive theory. So what do you think the secondary colors are going to be? You can probably guess it. Now, if you have a color printer and you're like changing out the toner cartridges, you may notice this. They are identified as cyan, magenta, and yellow, or sometimes they're just C, M, and Y. That's from cyan, magenta, yellow. There's also usually black, because mixing those together is supposed to give you black, but it's not a really true, good quality black. So you'll usually have a black toner cartridge in there as well. Okay, guess what? When I mix them in pairs and get the secondary colors, I get red, green, and blue, which would make a whole lot more sense if we started drawing the pictures of how things are getting reflected, and we'll do that at some point, but not right now. Okay, what should we be able to do right now? Well, we should be able to identify the primary colors and secondary colors of both the additive theory and the subtractive theory. We should be able to describe how we perceive colors. So in other words, light being reflected. Well, what color is being reflected and what colors are being absorbed? And we will get more practice on that, and we'll get very specific about what happens when you shine white light on a cyan object. What happens when you shine red light on a cyan object? We'll go through all of those kinds of details in the coming time. But for right now, that gives us an introduction, and we'll talk to you another time.